All right. Hey guys, this is Mrs. Lyons, and I am going to work through the molarity practice in this video. So what we need to know in order to figure out molarity or solve molarity math problems, we need to know that molarity, big M, is equal to moles of solute over liters. So I'm just going to put moles over liters. Okay. So every time you start a question, what you're going to want to do is you're going to want to define those variables and see what you've got. So I would start every problem like this. All right. And then I'm going to read my question. What is the molarity? So this tells me right off the bat that I'm looking for molarity of a 0.3 liter, so that's my liters, 0.3 liter solution containing 0.5 moles of NaCl. So this one has two of the three variables, so we're good to plug things into our equation and solve. So this one, molarity, is going to be equal to 0.5 moles over 0.3 liters. All right, so let's find my calculator. All right, so we have 0.5 divided by 0.3 gives us 1.6 continuing. So we're going to say that that is 1.67. Our units are either going to be big M, which stands for molarity, or we could write 1.67 moles per liter. Either one of those units are correct. If you use the big M, when you read this, you would say, I have a 1.67 molar solution. Okay. All right, let's look at question number 2. If A, so I'm going to put my variables here again, molarity, moles, liters. If a 0.075 liter solution, so I've got my liters again, 0.075, contains 0.0877 moles, okay, so I've got 0.0877 moles of copper carbonate, what is the molarity? So again, this is a pretty straightforward one. We're just plugging the numbers into our molarity equation. Molarity is moles of solute divided by liters of solution. All right, so the molarity is going to be 0.0877 moles over 0.075 liters. So if I plug this into my calculator, 0.0877 divided by 0.075 is I'm going to put 1.17. All right, 1.17 molar. I'm going to put a box around my answers. All right, number 3 is a little bit different, but it's still not bad. So we still need molarity, moles, and liters. All right, so this is what volume of a 0.25 big M, so a 0.25 molar, so that goes here, 0.25 molar solution can be made using 0.55 moles. So this gives us our moles, 0.55 moles of calcium hydroxide. So we're looking for the volume. Liters are our units for volume. Okay, so now if we plug this into our equation, what we get is 0.25 is molar is equal to 0.55 moles over X liters. Okay, now the algebra on this one just always seems to get people. Okay, so I'm going to go through this algebraically and show you what you should do. Okay, so if I want to get the X by itself, the first thing I'm going to do is I'm going to multiply both sides by X liters. Okay, Now, what that does is it cancels out the x over here. So I end up with x times 0.25 is 0.55. I'm going to write that. And I'm just going to put x. X times 0.25 is equal to 0.55 moles. All right. So now to get x by itself, we're going to divide both sides by 0.25. So this cancels out. So x is going to equal 0.55 divided by 0.25. So let's see. So 0.55 divided by 0.25 is 2.2. Did I do that right? Let's double check that. 0.55 divided by 0.25, 2.2. All right. So I have 2.2, my units, I'm looking for liters. So my answer is 2.2 liters. Now, I know that that takes a minute to do that algebra, but take the time to do it, okay? Because if you don't, so many people miss this type of problem because they mess up with the algebra, okay? You know how to solve it chemistry wise, but you're kind of rusty on your algebra. So work on that. All right, number 4. Molar, moles, liters. Okay, what is the molarity? So it's asking us to find big M molarity of 650 milliliters of solution containing 63 grams of sodium chloride. Now this one is a problem because we don't have moles, we don't have liters. So we have to do something with what we have, okay? Remember that if we have milliliters in our problem, we can move the decimal 3 places. So 1, 2, 3 to have liters. So I would have 0.65 liters. Okay. I don't have moles either, but I have grams. All right. So 63 grams of sodium chloride. So I'm going to figure out how many moles that is. So 63 grams of NaCl. I'm going to do a mole conversion just like we've been doing all semester. All right. So I have to look at my periodic table. And when I do, what I'm going to see is sodium is 22.99 and chlorine is 35.545. So let me add those together. So 22.99 plus 35.45 is 58.44. That's the number of grams, that's the molar mass of sodium chloride. Grams is going to go on the bottom. On the top is going to be 1 mole. All right, so if I want to do this math, I'm going to do 63 divided by 58.44. And I get I'm going to go with 1.08. Now that's the number of moles, 1.08 moles. So now I have what I need to plug into my equation, all right? So molarity is going to be equal to 1.08 moles over 0.650 liters. I'm just going to, whoops, I guess I'm not. I was going to carry that number and I hit clear. 1.08 divided by 0.65 is 1.661. So my molarity is 1.66 big M molar. All right. So these problems aren't terribly hard. It's just a matter of reading and figuring out what you need to plug in for each of the variables. All right. So number 5, moving on to number 5. Again, I'm going to say big M moles liters. What volume, so this is telling me I need to find liters, of a 0.88 molar solution, so that's big M, so 0.88 is the molarity. Solution can be made using 130 grams of iron chloride. Okay, so we've got grams. We need to use our grams, use our molar mass to figure out the number of moles. So I'm going to do that. I've got 130 grams of FeCl2. So I need one iron. So iron, if I look at my handy dandy periodic table that I have on my phone, so I always have a periodic table with me, I can figure out that I've got one iron, so that's 55.85. And then I've got two chlorine, which are 35.45. And I've got two of those. So I'm going to add this up. Let's see what I get. 55.85 plus 35.45 plus 35.45, 126.75. That's the molar mass of iron chloride. And I kind of messed that up. I'm going to write this over here. So I have 130 grams of FeCl2. I have to convert that to moles. So my molar mass, 126.75, is going to go on the bottom, and 1 mole is going to go on the top. Okay, so I can do 130 divided by 126.75. So I have 1.03 moles. Okay, now I didn't leave myself enough room to write here. So now I need to solve. So I'm going to try to do that over here. So 0.88 big M is equal to 1.03 moles over X. All right, so we have another one of those problems where the algebra can be a little bit tricky. So I'm going to kind of draw a box down here that I can work in. Okay, so I'm going to multiply both sides by X. All right, I'm going to write it down here. That gives me 0.88 times X is equal to 1.03. All right, now I'm going to divide both sides by 0.88, and that's going to give me X. So 1.03 divided by 0.88 is 1.17. So I need 1.17 liters. Okay, that is my answer. And this makes me think about asking you to do one thing. When you solve this kind of a problem, put a box around your answer so that I know what you think the answer is, so I don't go and be like, oh, 1.03, that's not right. Put a box around your answer. All right. Okay. Number 6. I'm going to put my units over here. Molarity, mole, liter. All right. How many grams of calcium hydroxide are needed to produce 500 milliliters of a 1.66 molar solution? So I have the molarity here, 1.66 big M. I have milliliters. I don't have liters, but I know that I can move the decimal back 3 places. 1, 2, 3. So this is going to be 0.5 liters. All right. I can't solve directly for grams, but I can solve for moles. And once I know moles, I can figure out grams. So we're going to plug this in. 1.66 is equal to X moles over 0.5 liters. All right, so this one's pretty easy. I can just cross multiply. I can multiply both sides times 0.5. Okay. What that does is it gives me X by itself. So 0.5 times 1.66 is 0.83. All right, so I have 0.83 moles. Okay, now what I got to do with that now is figure out how many grams. So I'm going to go from moles to grams. So I'm going to start over here, 0.83 moles of calcium hydroxide. I'm going to convert to grams, so 1 mole goes on the bottom. And then on the top, I have to add up the molar mass of calcium hydroxide from my periodic table. All right, so let's look at my periodic table. Here we go. So calcium is 40.08. I'm running out of room. I'm going to kind of write this over here in the margin. 40.08 is calcium. That's 1. We have 2 oxygen. We know that oxygen is 16. So 2 times 16 is 32. And then we have 2 hydrogen. Hydrogen is 1.01. So we've got 2 of them, so 2.02. So let's add these up and see how many grams. What's the molar mass? So 40.08 plus 32 plus 2.02, 74.1. That's our molar mass. Okay, so 74.1 grams of calcium hydroxide per 1 mole. All right, so I'm going to do 0.83 times 74.1, and I get 61.50. 61.50. What the heck is that I just solved for? Moles cancel out. I've got grams. All right. So that was kind of a steppy problem that you had to really think about what you were looking at, what you were solving for, and what you were given. All right, one more. Number 7. How many moles, so we're looking for moles, of sodium chloride are present in 600 milliliters of a 0.155 molar NaCl solution? So this one I've got 1.55 molar. And it's telling me I have a 600 milliliter of solvent, okay, of solution. So I'm going to move my decimal place 1, 2, 3. So my volume, my liters, is 0.6. All right, so this one's pretty straightforward. We can just plug this into our equation. 1.55 is equal to X moles over 0.6 liters. If we multiply each side by 0.6, all right, we'll get our answer. So 0.6 times 1.55 is 0.93. So this tells me that I have 0.93 moles. All right. So hopefully just running through and practicing those problems, hopefully that was helpful. Hopefully it helps you see kind of how to think about this type of problem. I hope that helps. Take care, and I will see you in class.